Hello and welcome to my new channel. The objective of this channel is to explain mathematical and scientific concepts in a simple enough way so that hopefully anyone with a little bit of interest will be able to get some deeper understanding afterwards. Don't forget to subscribe and hit the bell button, that way you will get notifications on new content. Also feel free to comment below. I will try my best to read all of them and to answer any questions you might have. If you liked the video, then hit the like button, and if you for some reason didn't like the video, then just give me a dislike. Without further ado, let's get on explaining what the Pythagoras Theorem is and how to deduce it. Pythagoras Theorem is a geometric relationship named after the Greek philosopher Pythagoras, who lived between 570 to 495 BC. However, the theorem is much older than that. Its use was widespread in the old Babylonian era about 1000 years before Pythagoras was born, and it might be even older than that. Where it comes from, who invented it, or when it was invented, is shrouded in mystery. Pythagoras' theorem was mentioned in Euclid's Elements, which was written around 300 BC, in which the first known proof was provided. Today there is a plethora of different proofs and deductions of Pythagoras' theorem, but in this video I will provide my personal favorite, which is a proof of Pythagoras' theorem using the method of similar triangles, which is an axiom described in Euclid's Elements. This proof, or deduction if you will, is, at least in my opinion, very easy to understand. So, what is Pythagoras' theorem then? The theorem describes the relationship between the sides of a right triangle. Here is an example of a right triangle. It means that one of its corners has an angle that is 90 degrees. This is a very special kind of triangle in mathematics, and it is a very useful special case that is used in many branches of mathematics, science and technology. Here we see the right triangle with its sides A, B and C. The sides A and B are perpendicular to each other. A common name for these sides is the cathetus, which means a leg. Then there is this side C that is a bit different than A and B. It is always longer than A and B. This side is called the hypotenuse, which literally means subtending the right angle. The theorem then states that taking the length of the hypotenuse, namely C, and squaring it, that is, multiplying C with itself, is equal to the squared length of cathetus A plus the squared length of cathetus B. So, in order to find the length of C, you just have to take the square root of the whole thing. Then, to find the length of side A, then you take the C part and subtract the B part. And to get the side B, you take the C part and subtract the A part. It is just a matter of rearranging the terms. Now to the deduction part. We will now try to use the axiom of similar triangles in order to find ourselves back to this equation again. Because of the fact that this is a right triangle, we can split this into two new subtriangles, which are also right triangles. As we can see, they make a right angle with the hypotenuse and thus splits the hypotenuse into two parts, x and y. We identify that C equals the sum of x and y. The nifty thing about these two new triangles is that the ratio of the short cathetus to the hypotenuse is the same for the mother triangle and the two child or subtriangles. The same goes for the ratio of a long cathetus to the hypotenuse, or any other side length ratio for that matter. If we use these relationships, we can identify that the ratio B over C is identical to the ratio y over b. This is because b over c is the short cathetus over the hypotenuse in the mother triangle, and y over b is also the short cathetus over the hypotenuse in the upper subtriangle, because in this triangle b has suddenly become the hypotenuse and y its short cathetus. These ratios must be identical because all the three triangles have the same shapes. Only their sizes are different, but that doesn't matter when comparing the ratios of the side lengths. Furthermore, the triangles must all have the same shape, because there is only one way to get a right triangle within another right triangle when splitting it like this. Then we will do the same with the ratio of the long cathetus over the hypotenuse. Then we get that the ratio of a over c is the same as the ratio of x over a, because in the lower subtriangle, the cathetus a now plays the role of being the hypotenuse and x represents the long cathetus. If we move the denominators on the right hand sides over to the numerators on the left hand sides with a little algebraic manipulation, we can see that we can simplify the expressions so that b squared over c equals y and a squared over c equals x. If you remember, in an earlier step we split c into x and y, so therefore we should be able to substitute x and y with their respective fractions that we have just established. Now we have that c equals to a squared over c plus b squared over c. Simplifying the denominator on the right hand side allows us now to move the c to the left hand side, and we get c multiplied by itself, that is c squared. And on the right hand side, now only the sum of a squared and b squared. And thus we have proved the Pythagoras Theorem. I hope that this video has been helpful to you. Please subscribe, hit like or dislike and comment. I'm looking forward to meet you in the next video. Bye!